Welcome to Ask and Learn.
All right, so here we're being asked to find the number c that satisfies the conclusion of the mean value theorem on the given interval. And we're being then asked to graph the function and the secant line through the endpoints and a tangent line. And the question is, are the secant line and the tangent line parallel? So in order to first proceed with this problem, we have to figure out whether this function f of x equals e to the negative x satisfies the condition for the mean value theorem. And since e to the negative x is an exponent function, we know that they are always continuous and differentiable on its domain, which is all real number. So we know that these two are definitely satisfied. So we now know that we can go ahead and proceed with the conclusion of the mean value theorem. And so the conclusion of the mean value theorem, as you recall, is that there's a number c such that in the derivative of f prime of x, it is equal to the average slope but in its interval. So in this case, it's f of 2 minus f of 0 all over 2 minus 0. So we're just going to go ahead and first of all just find the average slope, just to make this easier. This is much longer algebraic problem, so we're just going to find the average slope. The average slope is f of 2 minus f of 0, but we're going to go ahead and plug in the value. So e to the negative 2, that is f of 2, and then minus e to the negative 0 all over 2 minus 0. Now e to the negative 0 is just any number raised to the power of 0 is 1, so this simplifies down to e to the minus 2 minus 1 over 2. So this right here is the average slope from on 0 to 2. So what this number is this is the average slope. So this is how we get our first secant line. So this is our secant line equation. So this is going to be y equals e to the minus 2 minus 1 over 2 x. This is our first secant line equation. This is an important thing to remember. So now the question is, we want to find where the tangent line is equal to the same slope. So essentially we're looking for a line that's parallel. So the way we do this is we take the derivative of this. So we're just going to go ahead to the next clean page. So recall that the function was e to the negative x. Oops. E to the negative x. And so by taking the derivative of this prime, we'll have to apply the chain rule. So we will take the derivative of negative x, which is negative 1, and then the derivative of e to the x is just e to the x, and we keep the same upper bound, so it'll be negative e to the x. And now we're going to apply this, we're going to rewrite this in terms of c's to apply this to our mean value theorem. So we're going to go with e to the negative, there'll be negative 1, e to the negative c equals the average slope. But remember, we already calculated our average slope, which was e to the minus 2 minus 1 over 2. So now, now we just have to isolate the c. And at this point, it's just a lot of algebraic manipulation. But we're going to bring this negative 1 over here, and we're going to switch these two values to actually apply it. So e to the minus c equals 1 minus e to the minus 2 all over 2. And then we're going to take the natural log on both sides. So we're going to apply natural log, because that's how you get rid of the exponent function. And we're going to apply the natural log. I'm going to move up here. So when you apply the natural log, this exponent goes away. And all we're left with is negative c equals ln of 1 minus e to the minus 2 all over 2. And then we can plug in c is just negative ln of 1 minus e to the minus 2 over 2. Oh, 1 sec. All over 2. Yeah. So this is our value of c that we want. So now, in order to find the actual tangent line, remember that this is this is just a c. So we want to plug this in. We want to find the actual tangent line. And so the way we do that is we do this with the point slope formula. So basically what we're going to write is, what we're trying to find is this value of y. And we do this by taking the point at c, which is f of c. And then this will equal to the slope, but we already calculated the average slope. So e to the minus 2 minus 1 all over 2 times x minus c. And then we're going to bring y equals, we're going to rewrite this. Oops. Sorry about that. We're just going to just doing some algebraic manipulation. We're going to bring the f of c to the other side. And now we're just going to plug in our values. So we know our c from here. And we know our f of c because we can plug this in. Recall that it was e to the negative x. That was our original function. So now instead of putting an x, we're going to put in our value of c here. So when we do that, we get y equals e to the minus 2 minus 1 over 2 times x minus, and then our c is negative log, so it's going to be positive log now. The positive log of 1 minus e to the minus 2 all over 2 plus e to the negative, and then now we're going to put in our value. Since there's a negative ln of 1 minus e to the negative 2 all over 2, this creates a positive. And essentially this is our slope right here. And if you just do some algebraic manipulation, you're going to find out that this function is the exact same slope, which we can see right here. This has the exact same slope as our original function that we highlighted. This is the secant line, and this is the tangent line equation. This equation right here is the tangent line. And so by just looking at this, we can see that the values are just simply being moved up, and this e to the ln will also cancel, and then we're just going to be adding this value. So essentially, this function right here is just the same as this, except shifted up by 1 minus e to the negative 2 over 2. So the question of whether are the secant line and tangent line parallel? Yes, it is. And we know that because we can simply look at the slope.